Hello guys, today I want to talk to you about reduction using lithium aluminum hydride. Now in chemistry, lithium aluminum hydride is considered to be one of the strongest reducing agents. The most important thing about lithium aluminum hydride before we try to understand its mechanism is the structure of lithium aluminum hydride. Usually aluminum, which is having a valency of 3, is having 3 bonds with the hydrogen. Now, I introduce a lithium plus in order to stabilize the structure. But after this, we are forcefully going to introduce a hydride group, that is another hydrogen, which makes the formal charge of aluminum to be negative. Now, using this one feature or one characteristic of lithium aluminum hydride, we try to use that as our reducing agent. Now, where exactly do you think it works is the fact that this is so special because it can work on any of your carbonyl compounds, your amide compounds. What I mean by all the carbonyl compounds is whether I have a simple formaldehyde, our lithium aluminum hydride works. Whether I have any other aldehydes, still this works. Or for a fact, if I have all the ketones, it still works. If I replace it with your esters or with your carboxylic acid, lithium aluminum hydride considered to be a very good reducing agent. Now, assume how do I try to solve, or how do you think you should solve if you ever see lithium aluminum hydride to be one of the reactants. Let me take a simple case of a ester in which the reactant is your ester and you have your reagents to be your lithium aluminum hydride. If it is your exam purpose, all you'll have to do is, because your lithium aluminum hydride is consisting of that extra H, introduce a H here and convert this carbonyl group to a OH and remove this. Cleave that, and that will basically be your product. But how exactly do you think I write the reaction is the fact that take your carbonyl compound, write the carbon as it is, entirely cleave this group to make it into your H and introduce a 2H because you are trying to remove and convert it into its corresponding alcohol, and convert the carbonyl group to a functional hydroxyl group. Now, this is the easiest way that if you ever see an ester, convert, cleave it, make it into an alcohol in terms of your exam perspective. Now, similarly, if I have an acid, the rules remain the same. That is, cleave the hydroxyl group and convert it into a hydrogen group, introduce another hydrogen, and whereas convert the carbonyl group into a hydroxyl group. So if it is your exam perspective, if you see an ester or an acid, this is the easiest way for you to understand how to immediately predict what the product is. Now assume guys, you want to exactly know why this works or how this works is through the mechanism. So let's try to understand how exactly lithium aluminum hydride acts on any carbonyl group. So I am going to consider a simple ester in the presence of lithium aluminum hydride. Lithium aluminum hydride, and I have written the formal charge of the aluminum to be negative, and as we know, this is your electrophilic, this carbon is your electrophilic carbon, and this is your nucleophilic center. And if I look here, my aluminum is having a formal charge of negative, and I have a hydride group where I take one of the electron rich bond of lithium aluminum hydride and try to attack my electron deficient carbon. Now exactly the mechanism goes like, if I ever take one of the hydride groups and attack my carbonyl carbon, now you know that carbon is only supposed to have 4 bonds, but right now I'm trying to introduce a 5th bond, which means the carbon has to sacrifice one of the bonds, because of which one of the bonds will be pushed outside. Now you will realize that don't change anything else. Now I just have my OCH3. This can be any group which you can take, and here I have a O minus, and because I have used one of the bond to be inserted here, I am going to introduce this, the other H. Now the intermediate, if you want, you can write it as AlH3, because this bond you're cutting and you have your lithium plus. So now this is the intermediate step of any of your first step of reduction using lithium aluminum hydride. Now in the next step, what happens? Because this is a very highly electronegative atom, now if it ever decides to come out, and due to this nature of it being bulky, you realize that this is a very good living group. So because of which you notice there is a CH3O minus, which has a very good living group. Now if I rewrite everything, it will become like I have a double bond and whatever is the group there and a hydrogen. So now you realize whenever I'm doing a reduction of any of my ester, my intermediate is always a aldehyde. And as usual, because lithium aluminum hydride is a very strong reducing agent, the reduction does not stop at just the aldehyde stage, but rather continues further. And if you want, if you are ever given an aldehyde, you can use the same mechanism from here onwards. Or if you are ever given an ester, you can continue till here and then understand what is exactly happening. So now let's take the same case. Assume that I have my aldehyde. So I'm just going to write my aldehyde here. And as usual, I'm going to take my lithium aluminum hydride. And as in the same case, I'm going to use my hydride, electron rich, to attack my electron deficient carbon. And as usual, one of the bonds is shifted. And then you notice O minus. This H which I'm introducing is this H, right? And even if it's not mentioned, everyone knows that if you ever have a reduction using lithium aluminum hydride, the final step is a hydrolysis, which means this gets the final proton from the water to become your corresponding alcohol. You will realize that any aldehyde, depending on whether you take formaldehyde or your normal aldehyde, so I'm just going to give a chart to understand what kind of alcohols you can get. If you ever start with a formaldehyde, you're always going to get a primary alcohol. If you are ever going to start with any other aldehyde apart from your formaldehyde, you're always going to end up with a secondary alcohol. And if you ever have a ketone, the mechanism is the same, of course. You'll always be ending with a tertiary alcohol. Now, I have tried to tell you about how an ester works, how the reduction of an ester works, and then how we can convert ester to an aldehyde and aldehyde to a alcohol. Now assume I'm just going to talk to you about how the acid works. Let's take an acid. The mechanism, the overall, the way acid reduction happens is slightly different. And as usual, I have my lithium aluminum hydride. But instead of directly attacking my electrophilic carbon or the electron deficient carbon here, the lithium aluminum hydride, still the hydride, which is very electron rich, tries to attack an acid, because you know acids will easily give away that weak proton, and there is an elimination of your H2 gas. and you get an intermediate like O minus. This is basically your carboxylate ion. Take it, react it with the remaining lithium AlH3. Even though the lithium aluminum hydride has lost one of its hydrogen, it is still, the hydride is still considered to be electron rich, because of which you will notice they are going to use the hydride group once again. Again, it is going to attack my carbonyl carbon. This time you will realize that, oh, the mechanism remains the same. So this H is this H, and from here, if I ever decide that I have AlH2, which is my last remaining part of my lithium aluminum hydride, that the carboxylate ion, if it decides to come back, now this acts like a very good living group, and you notice that they live and they take the help of your H3O plus to go out as AlOH3, and you get back your aldehyde. So basically, whether you start with an ester or with your carboxylic acid, the intermediate will always be an aldehyde, where the reduction does not stop at your aldehyde but continues further to become the corresponding alcohol. So now you can make a small summary note telling, if you ever see lithium aluminum hydride, which is considered to be a very strong reducing agent, and you see any of your carbonyl groups, whether it is your aldehyde, ketones, your esters, or your carboxylic acid, they all get converted to their corresponding alcohols. Hope you really understood the mechanism, the overall reducing nature of lithium aluminum hydride. Thank you.